Hello YouTube, thanks for tuning into my channel today. It's funny how we say tuning into the channel when it's actually a click to the channel, but I digress. What I'm doing today is, first of all, we're in the shop. This is typically my wood shop, but I kind of tinker around with stuff out here as well. And what I'm doing today is I'm going to make an antenna. I've never operated 6 meters, ever, mainly because I never had an antenna for it. And I looked high and low online to find the right antenna. I didn't want to just do a dipole. I wanted something that was a little more omnidirectional. So I looked online and I found an antenna called the Squalo. It's a square halo design. And the site I found, I'll put it in the link below, but it's Papa Alpha 3 Hotel Charlie Mike. Has the plans for this online. I printed this out. And that's the antenna I'm going to build today. So stay with me and we'll see how it goes. Now, first off, I had a lot of scrap 1/2-inch plumbing. Let me move this bag out of the way. I also had a bunch of elbows and some other copper hardware that I thought I could use because I was actually starting to experiment with it already, how I can make the connections to connect the cable. The first thing I see from the plans is he's got 1, 2, 3, 4 pieces that are 14.0 inches, and then he has 2. These are the sides that are 27.56 inches. I'm thinking 27.5 will probably be close enough. So, and this section here in the middle, it says adjust length to balance on mast. We'll figure that out after we put it together. So let's. I'm going to start cutting first and get myself 2 27.5-inch pieces and 4 14-inch pieces of copper. Now these dimensions are to the center of the elbow. So before I go ahead and cut that, yeah, interesting. I want to subtract a 1/2 inch because it looks like it's about 1/4 of an inch short of the center of the elbow. Yeah, so I think that's what I'm going to do. I'm going to cut it so that these are really 13 3/4. And that will get me 14, should get me 14 to the center. But we'll find out. If it's not, I can cut another piece. Let me just cut one and we'll see how those dimensions work. So 13 3/4. Nice sharp point pen. And where's my mark? There it is. All right, let's snug this guy up here. There we go. Okay, now I'm going to just dry fit these into the elbows, and let's see now if we have 14 inches on center. Yep, we do. So that works. That's good. Okay, I'm going to continue cutting more pieces. Just going to dry fit everything and make sure everything lines up, and then we'll go from there. Okay, I've got the 4 14-inch pieces cut. Next I'm going to do is the 2 sides. Now the dimensions call for 27.56 inches on center. I'm going to go take a 1/4 inch off like I did on the 14-inch pieces, and we will go to 27.25. It's funny, this shop is usually where I do all my woodworking, and this is kind of fun doing something different out here rather than I mean, I love doing woodworking projects, but this is fun, making an antenna. I haven't done this in a long time. This section here, I've got all these pieces all cut. You'll notice that's insulated. We'll figure that out with a piece of PVC, I think. These are all cut. It's this section I've got to work on next. This is 2.5 inches on center. So we'll figure that out. and cut those pieces. Okay, so I cut this piece. 2.5. I just took the what I've been doing, taking a 1/4 inch off, and I'm 2.5 inches from on center. So we're good there. So now he's got this. Adjust length, that's this piece here, to balance on the mast. So I'm going to take a guess to start with this, and go with, these are 27, or yeah, a little less than 20, a little more than 27, but there's going to be a little more connectivity and stuff back here. I don't know, maybe I'll go 13 and well, a little less than 13 and a half. Maybe we'll make this 13 and a 1/4 in here, these two pieces, and see how it balances. And here we are, dry fit. So it's looking like the drawing does, right? Dry fit. We haven't sweat any of the elbows or anything like that yet. I just wanted to get a dry fit. I'm going to double check all these dimensions and figure. I've got an idea for how I want to connect that. I've been sweating pipe for years, so it's not something I can't do. But you know, it's funny. I'm not a plumber, so whenever I do plumbing repairs with copper and I sweat it, I do actually kind of sweat. I sweat it to make sure that the wondering whether the connections are good and we're not going to have a leak after I turn the water back on. But the good news is with this project, there's no water in it, so we can just sweat it together and make a good electrical connection. We're going to start with what I think might be the trickiest piece. This little piece. I have to sweat both sides of this, and you know, of course, when you make one hot, the other one's going to get hot. So we have to kind of flow the solder, I think, on both at the same time. So we'll do that first. We also have to make sure that this is not torqued like that at all. So what I'm going to do that is just put it flat on the bench, push down on it, and make sure I've got them in line with each other. Flux on a brush, just kind of brush it onto the copper. That light you just saw go off would be my garage door opener light that is motion sensitive. So you know what, I don't think we're going to do crazy. I think this will be just fine. Should be enough flux to flow into the elbows. Okay, I'm going to put it in my clamp. All right, let's see how the old guy remembers how to flow some solder here. There we go. There's the first connection. We'll let that cool a little bit, and then we will make our way around the project. This is pretty neat. One of the nice things about sweating pipe the old-fashioned way is you can use the capillary action of the heat to pull the solder into the connection, and it can go up. So you don't have to try to have things facing down and try to let the solder flow down, because if that happens, what can happen is the joint, the little copper, the elbow can fall off, and you're starting over again on that joint. So I learned, that's one of the things I learned along the way. I'm no plumber, so don't take any of these little morsels of information and think that I'm an expert at sweating pipe, because I'm far from it. But I think for this we'll be fine. You know, I was just thinking as I was putting this project together that what if it doesn't work? What if I hook it all up, build the antenna, and it just doesn't work? Well, okay, I got a little practice in sweating pipe again, which I haven't, like I said, I haven't done in a while. Luckily, we haven't had to do any kind of plumbing work around the house here, so that's a good thing. Okay, back over to the bench, and now we're going to be putting the elbows on that little center section that will feed out into the rest of the antenna. A little bit of heat. And we wait for the solder to get pulled into the joint. There it goes. Okay, I'm about to sweat up the last two pieces, and that's these corners here. Everything else is all sweat. All the connections are made. I'm propping up this side. You can see I've got the back of the radials kind of propped up off the bench. Just to kind of, I think, to maybe square it up. At least I'm convincing myself that's what it's going to do. So let me sweat this up, and then we'll see what I can do with those end pieces over there. So here's my thought for that center section out of the far end of the antenna. was going to take a PVC. I want something, obviously, that's not conductive. And here's what I noticed. The 1/2-inch pipe that I used to make the antenna and this piece of PVC, you'll notice the pipe does not slide right in. So I'm thinking, I cut this 3.5 inches. If I just open it up, maybe, 1/2 inch on each side, that leaves me 2.5 inches, which is what the spec calls for the open end of the antenna. If I open it up enough for the pipe to fit in, but don't go all the way in, it'll feel like I have a shoulder inside the pipe. That will stop. That should stop that. We'll try it, see if it works. Well, it sort of worked. I took my drill with the largest bit I have. This is just over a 1/2 inch. This is a big, 35/64, right? Just over a 1/2 inch. This is a big bit. I made a mark to show my 1/2 inch depth. Right there. And I drilled it out, took a couple of shots, but one side, it's a nice snug fit. I'm thinking of just putting a screw right here to hold everything in place, but that works. And what that'll give me, this is 3.5 inches, so take a 1/2 inch off, that gives me a 2.5 inch distance between the two, right? Okay, so now that everything's manufactured and assembled, remember that dimension I said I guessed about 13.5? I should have gone an inch the other way, because now you'll see that it's pretty heavy to that one side. So that dimension probably should have been about 15.5, not 13.5. But I don't think it's horrible. I can probably come up with some sort of a brace for this down to the mast, or it depends how we clamp it to the mast. It might be fine. I'm not gonna worry about it right now. But right now, the whole frame is assembled. Looks pretty good. So next thing to do is to figure out how to connect the coax, the antenna connection, and also there's a little shorting stub that gets built into this thing, a little shorting strap. And I'm going to use these little cable clamps. I had already started fooling with it not too long ago. Made something like this. It fits right around the pipe. I'm going to try that. Come up with some hardware, come up with a way of attaching the coax and a shorting strap. Then I can bring the antenna analyzer out and see how it performs. Here's the idea for the shorting strap. I'm not crazy about it. I think I can come up with something better than that. And here's the idea to mount it with. Again, I think I can come up with something better than that. It'll be good to test it anyway. What I did find, and I want to try to use, I found a couple of these bolts with wing nuts. Use that for the coax connections. Here's how the shorting strap's going to get connected to the antenna, and I'll do the same where the coax connects somewhere in here. This dimension was given in the drawing, right here. So I marked it here on the pipe. So we'll match it, and again this will be all hook it up and then connect the analyzer to it. All right, so here we go. I kind of cobbled together something here to test it with. I've got a length of coax. This isn't pretty at all. Not meant to be. These didn't work out the way I was hoping they would, so I'm going to rethink this. Here's the shorting strap. Again, this whole thing can get rethought. I'm not crazy about it, but I think it's good for the test. So this is the 5.5 inches up that the plans call for, and down here we have a little more than 1.5 inches up from the center. So that's where we got these set up, and I brought the analyzer out. So I'm going to connect it, and then we'll see what we get. So I got it outside, got it up on this little plastic table to get rid of some of the ground effect, not a lot of it, but a rough test, and check it out. That's not too bad, right? Stand by, I'll run a scan for you. So, I don't know. I'm going to try moving it up a little bit and check the frequency. What I did see is, you know, all the mechanics here, I've really got to redo that. As I was moving things around, things were all over the place. So I know I need to do that. But hey, for a first pass, I think we're, I think we're doing pretty good here. So more to come. Stay tuned. Well, we did a lot of work between the last time I had it in the shop That was about 2 weeks ago, 2-3 weeks ago, and I've got it outside. I did some work. I replaced the screws with stainless steel hardware there, and I picked up a couple of clamps to clamp it up to a mast section that I had luckily in the garage, or actually in my shed. And now I've got the antenna. The way I trimmed it to get it to make it resonant, we adjust this for impedance, and then we adjust this for the feed point. Now I know this kind of looks like it's dead short, but it's not at 50 megahertz. Here's the feed, and then of course this is basically a dipole. In this section here, I had to trim it because it was resonant at about like the low 49 megahertz range, like 49.1. So I took this open, and I used a pipe cutter and just cut each side. Took about 3/4 of an inch off each side. And well, I'll tell you, I can show you what it looks like at 50.125. There you go, 50.125, 1.38 to 1 SWR. It's still resonant a little bit below 50 megahertz. I don't know if I can take much more off the antenna. I think 1.3, 1.4 to 1 is acceptable. So the next thing to do is to figure out where we're going to put it on the house. So stay tuned. Well, it's been a couple of weeks. We've had some really hot weather, and then we had a bunch of rain, and then I was out of town for a little bit. So we finally have some time to get the antenna up. It's built, it's finished, and I'll show you some pictures of it before we get up on the roof. But like I said, when the weather breaks, what does every good ham do? Well, he gets a ladder out and he starts heading up the roof. So that's what we're going to do today. But first, let me just show you the final product before it goes up. Well, it's kind of a busy shot. It's really with the grill and everything behind it. But let me just walk you through some of the things I did. I added a brace here to keep it relatively squared up to the pole, to the mast. A couple of clamps here to mount it. I redid all of this over in here, where my connection is. This is how it's going to look. There's a little tripod. I didn't have a tripod here, and believe it or not, there's no local place. Look, Radio Shack's gone, right? So couldn't get to the local ham fest last week, so hopped on Amazon. There you go. Got myself a quick tripod. It came today. So we're going to go up and put it up. Well, there she is. There's a Squalo up on the roof. And what I do is I have a pretty low loss cable, a hard line almost, that I ran. I did this to the roof a couple of years ago, and it's really come in handy having that access point for cable. Here's my tri-bander up here, and I did straighten out that element that was not where it should have been, as you noticed in an earlier video. And there's my 2 meter 440 vertical up top, and a little more of the antenna farm lower up here. Scanner antenna, homebrew. And there's the balun for the off-center fed dipole. One end goes up into that tree, you really can't see. And then the long end, you really can hardly make it out, goes out to the back corner of the yard. So that's the antenna farm. Well, I pulled the cable, I'm in the shack, and look at that. Look at that. Let's plug this baby in and see if we hear anything. I doubt it, but let's try it. Well, I'm gonna let you guys join me here as we fire up the FTDX3000 and see how things go. That's 40. Now let's go to 50.125. And I'm using antenna output 3, antenna port 3. There we go. So, all right, I'm going to go to the, somewhere in here. Let's just do a antenna tune and see what happens. All right, so here we go. Yeah, tuned up. Wow. Well, I wasn't copying it, but how about that? Looks to me like the antenna is a success. Well, I can't wait to have more fun with it. Well, sorry for the handheld look here at the end, but I'm pretty excited, pretty encouraged. I think this antenna is going to work fine. It took me about an hour today altogether, from getting the ladder out to mounting the antenna, pulling the cable to the house, and plugging it into the radio. So So I'm pretty excited. Like I said, I've never operated 6 meters before, so this will be all new for me. So I'm going to put the link for the plans down below. So if you're interested in building this antenna for yourself, it's not hard to do. It was a lot of fun, actually. And also, if you like the video, hit subscribe. That'd be great. Or just give me a thumbs up. That'd be awesome, too. So again, thanks everybody for watching and sticking it out for this project. And we'll see you next time. 73 from K2 CJB.